No one expected Venus to be alive in any sense of movement. Yet something on the surface, or perhaps above it, suggested otherwise. When Soviet engineers launched their deep space probe toward Venus, they believed they were studying a lifeless inferno of acid clouds and crushing pressure. But as the data began to arrive back on Earth, something inside the transmission didn't match expectations. A faint, repeated disturbance. A pattern. A motion that should not exist in such an environment. Scientists paused, rechecked, then paused again, because what they were seeing looked like something was moving inside Venus' atmosphere. Before we go deeper into this mystery, if you're fascinated by space anomalies, hidden cosmic signals, and unexplained discoveries like this, make sure to subscribe. Because what you're about to hear isn't just history, it's a question science still struggles to fully answer. Venus has always been known as Earth's hostile twin, a planet wrapped in thick clouds of sulfuric acid, where surface temperatures are hot enough to melt lead, and atmospheric pressure can crush anything that dares to land. For decades, scientists agreed on one thing: nothing could survive there. But during the Cold War space race, the Soviet Union attempted what many considered impossible: direct exploration of Venus' atmosphere using robotic probes designed to withstand extreme pressure and heat. These missions were not just scientific, they were strategic, symbolic, and deeply experimental. And one of those missions recorded something unexpected. Something that challenged the very definition of planetary lifelessness. In the height of space exploration rivalry, Soviet engineers launched a series of probes toward Venus, built to penetrate its thick atmosphere and transmit data before being destroyed by the extreme environment. These probes were not expected to last long. Some would survive minutes, others slightly longer. Their purpose was simple: send back atmospheric readings, pressure levels, and chemical composition before being crushed or melted. But one probe transmitted something unusual. Not just data, but disturbance. A repeated fluctuation in signals that did not match wind patterns or known atmospheric turbulence models. At first, engineers assumed it was interference, noise, a malfunction. But the pattern repeated, again and again. What made the signal disturbing was not its strength, but its consistency. It appeared as if something inside Venus' upper atmosphere was moving in a structured way. Not random chaos, not thermal noise, but rhythmic displacement, like something shifting through dense layers of cloud. Soviet scientists ran simulations. They compared atmospheric models. They checked for electrical interference. Nothing explained it. One researcher reportedly described it as like watching ripples in a place where there should be no water. The idea was controversial, dangerous, even, because it hinted at something unexpected. Venus might not be as inert as we believed. Within Soviet research teams, disagreement quickly formed. Some scientists argued the probe was simply misreading chemical turbulence. High-pressure sulfuric acid clouds can behave unpredictably under solar radiation. Others were less convinced. They pointed out that the movement pattern was too structured, too repetitive, too consistent to be natural atmospheric chaos. Still, caution dominated interpretation, because in science, especially planetary science, extraordinary claims require extraordinary proof. And at that time, there was not enough evidence to declare anything alive, or even moving intentionally. But there was enough evidence to say something strange was happening. As the probe descended deeper into Venus' atmosphere, the signal changed again. Stronger, more defined, more deliberate in structure. And what scientists recorded next would push the limits of what they thought a planet like Venus could possibly show. Something was not just occurring in the atmosphere, it was interacting with it. As the Soviet probe continued its descent into Venus' atmosphere, the transmissions became increasingly difficult to interpret. What began as simple atmospheric data slowly transformed into something far more complex. The readings showed fluctuations that repeated in patterns, almost as if the environment itself was responding to an unseen force. Engineers noticed that the signal distortions were not random. They followed a rhythm, an organized shift in density and energy readings. In normal planetary science, atmospheric turbulence does not behave with repetition. It collapses into chaos. But here, on Venus, chaos seems structured. This contradiction forced scientists to reconsider everything they thought they knew about atmospheric behavior on extreme planets. In Moscow's mission control rooms, analysts watched as the incoming data suddenly shifted. For several seconds, the signal stabilized into a clear pattern. A wave-like fluctuation appeared across multiple sensors simultaneously. Temperature, pressure, and chemical composition readings all showed synchronized movement. This was not expected. One engineer reportedly paused a recording and replayed it several times, convinced it was a technical glitch. But the pattern remained consistent every time. It was as if something inside Venus' atmosphere was moving through layers in controlled direction. Not drifting, not scattering, moving. Back on Earth, Soviet scientists gathered urgently. The data was sent through multiple verification systems, checked against backup recordings, and compared with previous Venus missions. Earlier probes had shown violent atmospheric conditions, yes, but nothing with structure. Nothing that suggested directional motion beyond wind systems. But this new signal was different. It suggested layered movement, almost like currents in a fluid responding to an external stimulus. Some researchers began to question whether they were misinterpreting atmospheric chemistry. Others cautiously suggested something far more controversial: unknown plasma interactions or energy-based phenomena within Venus cloud layers. Still, no one dared to propose a word life. Not yet. The most disturbing aspect of the data was not its complexity, it was its intention-like structure. The movement did not resemble random environmental forces. It resembled response patterns, as if something was reacting to the probe itself. One scientist described it in a classified report as a system that appears aware of intrusion, even if not conscious in a biological sense. That statement changed everything, because if the atmosphere itself could respond, then Venus was not just a passive environment, it was interactive. And that idea pushed Soviet researchers into uncomfortable territory. As the probe descended further, conditions worsened rapidly. Pressure increased, temperatures climbed, acidic clouds thickened. Yet the signal did not disappear. Instead, it intensified. The rhythmic fluctuations became sharper, more frequent, almost as if whatever was causing them was now closer to the probe's position. At one point, the transmission briefly showed what appeared to be localized disturbances, small, clustered variations in atmospheric density moving in a coordinated path. It lasted only seconds, but it was enough. Enough for engineers to stop speaking entirely in the control room, because they had just witnessed something that defied classification. At this stage, Soviet researchers split into competing interpretations. One group argued the phenomenon was purely chemical, an interaction between solar radiation and Venus-dense sulfuric acid clouds creating self-organizing turbulence patterns. Another group proposed electromagnetic plasma behavior, suggesting that Venus' upper atmosphere could host energy structures that mimic motion under certain conditions. But a smaller, more controversial group raised a more radical idea. What if Venus' atmosphere was not just reacting, but adapting? This theory was quickly labeled speculative, but it could not be completely dismissed, because the data kept repeating patterns that suggested persistence rather than randomness. Then something unexpected happened. The probe's transmission frequency began to fluctuate outside normal operational ranges. The signal became unstable, but not lost. Instead, it transformed into a repeating wave structure that resembled a response cycle. It was as if the probe and Venus were now locked in a form of interaction. Engineers tried to stabilize the system remotely, but the interference only increased. And then, just as suddenly as it began, the structured motion in the data became clearer than ever before. Something inside Venus' atmosphere was no longer just being detected, it was being observed, and it seemed aware of it. By this stage of the mission, Soviet engineers were no longer simply analyzing data. They were trying to understand behavior. The readings from Venus were no longer just environmental measurements. They had become structured patterns of movement that repeated with disturbing consistency. What made this phase critical was not the intensity of the signal, but its organization. Multiple instruments aboard the probe began reporting synchronized fluctuations across different atmospheric layers. It was as if separate parts of the atmosphere were moving in coordination. This kind of synchronization does not happen randomly in planetary systems. It suggests either an unknown physical mechanism or something actively maintaining structure within chaos. In classified Soviet analysis labs, scientists began plotting the probe's data into visual maps. These maps revealed something unexpected. Instead of random turbulence patterns, the atmospheric data formed clustered pathways, regions where fluctuations repeatedly appeared in similar locations relative to the probe's descent path. It looked less like weather, and more like movement corridors. One researcher described it as, something is not just occurring in Venus' atmosphere, something is traveling through it. The implication was never officially confirmed, but the internal reports show rising concern among mission analysts. Because if this interpretation was correct, then Venus' atmosphere was not static. It was dynamic in a way never recorded before. As discussions intensified, a controversial theory emerged within a small group of Soviet scientists. They called it the Red Line Hypothesis. It suggested that Venus' atmosphere might contain self-organizing energy structures, patterns that behave like moving systems when stimulated by external interference. According to this theory, the probe itself may have triggered a response mechanism within Venus' atmospheric layers. Not life in the biological sense, but something that behaves like a system that reacts, adapts, and stabilizes itself. The idea was highly debated, and many rejected it outright. But the data refused to contradict it, because every time the probe advanced, the atmospheric patterns shifted in response, almost like adjustment, almost like awareness. As the probe moved deeper, conditions became extreme. Pressure readings exceeded expected mission thresholds. Acidic density increased rapidly. Heat levels surged beyond calibration limits. Yet the signal remained. In fact, it became more defined. The fluctuations now appeared in tighter intervals, almost like pulses. Scientists noticed that the rhythm of these pulses seemed to align with the probe's own transmission cycles. This synchronization created an unsettling possibility that whatever was producing the movement inside Venus' atmosphere was not only reacting, it was timing itself, matching the probe, responding in real time. At this stage, Mission Control experienced something rare in scientific environments: uncertainty without explanation. There was no clear model that could account for the observed data. Atmospheric physics could not explain the structured movement. Chemical interactions could not produce synchronization at this scale. Electrical theories fell short under pressure constraints. What remained was ambiguity. And ambiguity in science is often where the most important discoveries begin, but also where confidence disappears. Engineers were forced to continue the mission without a framework to fully interpret what they were observing. The probe was still transmitting, but understanding had begun to break down. As the probe reached deeper atmospheric layers, the signal reached its most complex state yet. Multiple overlapping patterns appeared simultaneously, forming what analysts later described as layered motion signatures. These signatures did not behave like wind or turbulence. They behaved like structured flows moving in coordinated paths across different atmospheric depths. The most alarming detail was consistency. Every layer showed movement that was not independent, but connected, as if Venus' atmosphere was not a collection of chaotic gases, but a unified system responding as one. And at the center of it all, the probe continued its descent, still recording, still transmitting, still capturing something that no one fully understood. As the Soviet probe descended further into Venus-crushing atmosphere, conditions reached a level no engineering model had fully prepared for. Pressure values climbed beyond expected survival thresholds. Temperature readings surged into ranges where hardware degradation was not just likely, it was inevitable. And yet, the transmission continued. But what changed now was not the environment. It was the behavior inside it. The structured fluctuations that had once appeared as distant atmospheric patterns were now unmistakably closer, more concentrated, and more synchronized than ever before. It was as if the entire atmospheric system had narrowed its focus toward a single point, toward the probe. In the final minutes of stable transmission, Soviet scientists observed something deeply unsettling. The movement signatures were no longer just repeating patterns. They were evolving. Each cycle of fluctuation appeared slightly adjusted from the previous one, not randomly, but in a way that suggested refinement. The structure of the signal began to resemble feedback loops, as though the system was learning from its own responses. One analyst reportedly wrote in an internal note, "This is no longer passive atmospheric activity. This is adaptive behavior." That single interpretation changed the emotional weight of the entire mission, because adaptation implies interaction, and interaction implies response. Then came the most controversial moment in the entire dataset. For a brief window of transmission, all instruments aboard the probe recorded a perfectly synchronized fluctuation across every sensor channel. Temperature, pressure, density, and electromagnetic readings aligned into a unified waveform. Not chaotic, not random, unified. This event lasted only seconds, but it was enough to halt interpretation efforts entirely in mission control. Some engineers believed it was a system failure. Others believed it was the first time Venus had produced a fully coordinated atmospheric response. And a small number of scientists quietly suggested something far more unsettling, that whatever existed within Venus' atmosphere had fully registered the probe's presence, and responded as a single system. After this event, data quality began to degrade rapidly. The probe systems were under extreme stress. Signals fragmented, transmission intervals widened, noise increased. But even in degradation, the pattern did not disappear. It persisted. That persistence became the most important clue of all. Because even as hardware failed, the atmospheric structure being observed did not revert to randomness. It continued to show order, continuity, direction, as if something inside Venus' atmosphere was not dependent on the probe's survival, but independent of it. This forced scientists to confront a difficult question. Was the probe discovering a phenomenon, or was it briefly allowed to witness it? Then, without warning, the signal shifted one last time. A final burst of structured data was transmitted, strong, clear, and highly organized. It showed a rapid sequence of atmospheric movement patterns converging into a central region before dispersing outward again. No explanation was ever agreed upon. Some interpreted it as collapse of the system. Others saw it as withdrawal. And a few suggested it resembled something like observation ending. Immediately after this transmission, contact with the probe was lost. Silence followed. Not the silence of malfunction, but the silence of completion. To this day, interpretations of the Venus probe data remain divided. Mainstream planetary science leans toward atmospheric turbulence explanations combined with sensor distortion under extreme conditions. But a persistent minority of researchers continue to argue that the data contains structured anomalies that cannot be fully explained by known physics. They point to repetition, to synchronization, to directional movement, and to the final coordinated signal event. None of these elements alone prove anything unusual, but together they create a pattern that still challenges easy explanation. And that is why the debate continues. Because Venus, in this one brief moment of Soviet exploration, appeared to behave in a way that no one expected. What the Soviet probe captured may never be fully understood, It may have been extreme atmospheric physics operating at limits we do not yet comprehend. Or it may have been something more complex, self-organizing behavior within a planetary system we still do not fully understand. Or perhaps, just perhaps, it was something that responded to being observed. And if that is true, then Venus is not just a hostile world of heat and acid clouds. It is a place where even the atmosphere might not be as silent as we once believed. The question remains open. And in science, open questions are often the most important ones of all. If you found this investigation fascinating, make sure to subscribe to the channel for more deep space mysteries, hidden scientific anomalies, and unexplained cosmic events that challenge what we think we know about the universe. Because the next story might be even stranger than this one. And remember, sometimes the most important discoveries are not what we find in space, but what might be looking back at us. Stay tuned and watch till the end next time.